you. Today I'll be taking another example of regression analysis in R. So this is the Excel file I'll be using. So this is the gas price in US from the year 1982 to 2011 and for different months and the average and the index. So I'll tell you how to do the regression analysis for the average price. So let us see. So this is the source code for that. So these are the different panes in your studio. You can use this for seeing the different panes. So now I have written the program in the source pane. So I had to enlarge that. So this is the code for reading the Excel file to the to R. So it will be stored in the name gas data from gas underscore prices. So let us execute each command and see how it has been done. Okay. So I'm going back to show all the panes. So just you can see what are the gas prices. Okay, I have copied that, and gas prices is this one. Okay, this I'll remove all the variables and I'll start from the beginning. So first I'll read the file. So now I have read the file. Now let us see what is there in the gas prices. So gas prices, see I have read that file. Okay. So now what's the next? So I'm just plotting gas prices index and then average. I'm just plotting that. So to execute the command, you have to just enter control and enter. Okay. So that will come here. Okay. From the source file, if you want to execute one line, just click on that line and then press control enter. So now this is a plot for index. So here there's the index, one column is there, and average. I have plotted that. Okay. So this is the graph for that. You can see that. So now I am going to add a linear model. Okay. So linear model. So linear model of average versus index. Okay. So I'm just going to plot that. Okay. So now that line is plotted over the existing graph. So let us analyze that linear model. Okay. So I am copying the linear model to the variable results, and let us see the summary of that results. Okay. So what is it showing? So it is showing R square as 64%. So 64% of the variance is displayed in this model. So what is the model? Model is average versus index. Okay. So we are plotting that, and so the console alone I am showing. So this is the summary of the results. So this is the model we executed, average versus index, and this is the residuals. So median is around 0, and you got a p-value less than 0.05. So this is okay. And here you can see multiple R squared value is 64%. Okay. So 64% of the data is displayed by this model. Okay. So let us see another model. So as you can see from the graph, see it is not fitting properly. Okay, so let us try another model. Okay, so also one more thing you can see, you can check is that how will be the box plot of the residuals and whether it is normally distributed or not. You can just check that. Okay, this is a box plot and this is a histogram of the residuals. So now what I'm trying to do the quadratic or a square type. Okay, so for that I'm trying to find the square of the index. This is the code for finding the square of the index. Okay, and then I'm adding that index underscore sq or the square of the index to the gas prices. So we are using the function cbind, say gas prices, cbind gas prices comma index underscore sq. So now you can see one column would have been added to the, see this is also the square of the index is added, so one more column is added. So square of the index is added. So now what we are going to do, we are going to make a model of that. Okay, so now we added that index underscore sq to the gas price and you're going to make a quadratic model. So what is it? lm, I'll just make this big and also. Okay, so this is for making the quadratic model. So what I have used average tilde index plus index underscore sq. So I'm using the index underscore sq also, that column also I'm adding to the model, and data is gas underscore prices. Okay, so let us do that. Okay, so it will come in a new variable results underscore quad. Okay, so now let us see the summary of that. Okay, so summary, so you can see I call the summary of the results underscore quad. So here you can see 90% of the data is explained by this model. Okay, so this would be a better model than the other one. So let us see how that can be viewed. So now I am telling this quadratic model is better than the previous linear model, because as you can see the R square value is more and then the p value is less. Okay, so intercept is also having 3 star, index is having 3 star, and index underscore sq is also having 3 star. Okay, this is the model that we use currently. So let us see. So now let us see how this can be explained. Okay, like before, you can see the box plot of this one, box plot of the residuals of the both, and histogram also. Now I'm going to plot the index underscore sq and gas and average. Okay, so this is the plot for that. And then see, this is an important thing. This is a plotting. You will get the for graph you will get. Okay, you can see this is the residuals versus fitted. This is the smoothing curve. Okay, so here two outliers are there, 27th and 28th, because that is I think in year 1998 or something, oil prices dropped like anything. That's why the two outliers are coming mainly. Okay, and now if I type enter, so this tells whether your model is normal distributed. So you can see only 3 are away from the line, so this is more or less normal distributed, and this shows the scale and location. For standard is how it is far. Also same, you can see 27, 28 are far from this, And next one, show the cook distance. Cook distance tells you which outliers are more influential. This is the Cook's distance. You can see 27, 28 are near to the Cook's distance, and it is the most influential one. Okay. So now let us do the ANOVA. So two models I made, results and results underscore quad. So let us do the ANOVA and see. You can see the p-value is very less. So that means the second one. See, p-value is very less. Okay. So that means you can reject the null hypothesis and go with the second model. Okay. That is the conclusion of the ANOVA. And then I am predicting the values. Okay, I am predicting two predictions I am using for the quadratic model and also for the linear model with the index alone, and this with the index and index square. So I am predicting the values and I am adding that values. Okay, C-bind, using that C-bind I am just adding the values to the gas prices. Okay, you can see here that column would have been added. Okay, predicted price. This is the average in the original file. This is the predicted average using the quadratic model. Okay, and now I'm using the predict function for the linear model for the index alone, and then I'm adding that also to the gas prices. Now you'll be able to see one more column, predicted linear. Okay, predicted linear. So this has come. And then I'm going to plot for the index and average. Okay, and showing which you can see which one is better. So I'm index and average. Okay, I'm plotting index versus average, and then I'm adding the predicted value using the quadratic model to that using the lines command. So it has come. Okay, you can see this is fitting much better, and I'm also adding the linear predicted value also. I mean the predicted values using the linear model. You can see these are, so from this you can see the values predicted using the quadratic model is much better and it is fitting that curve. So this is one example I want to show you. So I'll do a recap. These are things I did today. I read the file and then I plotted. So the file is this one. Till here it was there. Average and index. This is what we plotted, index versus average. Okay, and then I added the linear model to that using the simple linear model, and then I plotted the box plot everything, and then I found the square of the index value. Square of the index value is nothing but the square of the index value, and then I made a model using the quadratic model, index square, index underscore sq, and index. So what you will get, so suppose the same thing. So if I execute this one, you can see intercept is 1.4. okay, and index, so the formula will come average equal to minus 0.1050369 into index plus 0.0055589 into index underscore sq plus the intercept, that will be the, so this is index square. Okay, if suppose you are taking this as x, this will be x square, 0.0055589 into s square or index square. So this is a quadratic equation formula. Okay, so these are the recap. So then I plotted for the gas in the square, and then I saw how it is fitting, and then finally this plot shows you are getting a good model with the quadratic one. So I use the predict function to predict the average value using the two models. To quadratic model is this one, and this is the linear model. So I use this one. So this is the program for this. I hope you understood. If any doubt, kindly get back to me. Thank you.